We will next talk about general elements of the machine learning pipeline. A machine learning pipeline describes how you go from raw data to trained machine learning model, and these steps are often very similar across different kinds of projects. So, once you have acquired your raw data, you will need to clean and pre-process it. What does this involve? Well, your data is often very messy, meaning that there might be errors in recording the data, and there will be a lot of missing values. You will then need to decide, do you try to fill in missing values, for example using averages, or do you throw away observations that have a lot of missing values, or do you throw away features that have a lot of missing values? And a lot of thought needs to go into that process. You will also pre-process the data in many cases, in the sense that some models will perform better if you scale your input features. So for example, you can subtract the mean divided by the standard deviation, which is called standard scaling. You do this for every feature, and then you will get mean 0 and standard deviation 1 features. Once you have your data in a format that is acceptable, you will then divide your data into training set, validation set, and test set. Sometimes just training set and test set. You will have usually a bunch of hyperparameters that you need to choose between. So you will have a learning rate that can be set at different values, which determines how slow or fast your model learns. And you can have different kinds of models. You could have a linear regression, or you could have a decision tree, which we're going to talk about very soon. For each choice of hyperparameter or model, you will train your model on the training set, then look at the accuracy or mean squared error, whatever metric you're using on the validation set. You can also use k-fold cross-validation if you want to be more sophisticated. You will then choose the model with the hyperparameters that has the best metric on the validation set. And using this best model that you found, you will then finally calculate your error on the test set. And this is what you will report because it represents an accurate assessment of how good your model is. In practice, however, people often look at the test set beforehand, and the distinctions do get a bit blurred.